Let's talk about exponential relationships. Exponential relationships shows quantities that increase or decrease rapidly over time. Exponential functions have a general form, and the general form for the exponential is y equals a times b to the x. Now let's explain a few things. A here is the initial value of the function, so where the function begins. It's the value of y when x equals 0, so that's the initial, right? X equals 0. Now, b of x is the growth factor in this case, and we have exponential growth when a is greater than 0 and b is greater than 1. So these are the conditions for growth. Any situation that describes a relationship that increases by equal factors over equal intervals is exponential growth. Now the key here is this equal factors over equal intervals. This is defining for either exponential growth or exponential decay. But because we're talking about increases over equal intervals by equal factors, then we're dealing with growth. Now, I want to practice just talking a little bit more. So if you were to graph an exponential growth function, what do you think will happen? So you're going to graph an exponential growth function, and we know that exponential equations are ones that rapidly change. So the y values either rapidly increase or decrease as the x values are increasing. So for exponential growth, what you will expect to see is y values that start close to 0. But as the x values increase, the y values will increase rapidly as well. So think about a coordinate plane. An example of an exponential growth curve would be something like this. Y values start off low, but then as x increases, all of a sudden y values jump up really quickly like that. So that's a gross representation of an exponential growth graph. So let's practice and let's solve a problem. Here you're given a table and you want to identify which equation represents the relationship that you have in the table. Now, these are all exponential relationships, so we want to think about the general form again, right? Y equals a times b to the power of x, where a is the initial value, and the initial value is when x equals 0. So that's one thing we need to consider. The other thing is we need to think about the growth factor, right? So B represents the growth factor. To find B, you divide each y value in the table by the previous y value. Now, why do you do that? Well, you do that because successive y values are multiplied by B as x increases by 1. What does that mean? Okay, so let's just talk about this in general before we solve this problem. So y equals a to the bx. Let's do this when x equals 1 and when x equals 2. So that would be this value and this value. Y equals a to the times b to the 1, or y equals a times b squared. Now, if you were to just write these out, right, this is equal to y equals a times b. Down here you have y equals a times b because you're now using the power of 2. Now that's why if you want to find the value of b, you're going to use division and you're going to divide the term that comes second here, so the x equals 2, by x equals 1. And we're going to find quotient for all of these relationships here. What's the factor, or the growth factor? What's b? So you're going to have 190, which is the value when x equals 1, divided by 38. And 190 divided by 38 equals 5. Now let's do 950 divided by 190. 950 divided by 190 equals 5 again. 4,750 divided by 950 now. And as you might guess, the value is 5. Now we know that b equals 5. So b equals 5. We've learned that from the table. Now again, the initial value. When x equals 0, what does y equal? When x equals 0, y equals 38. So that means a equals 38. So let's find something that has a equal to 38, b equal to 5. 190 times 1 to the power of x, that doesn't work. 5 times 38 to the power of x. 5 here is a, but we know that a has to be 38, so we're crossing this one off. Y equals 38 times 5 to the power of x. A equals 38 in this case. B equals 5. So here we are. We've identified the correct equation. For this table shown, the equation is y equals 38 times 5 to the power of x. Let's try another problem together now. Okay, what we have here is a t-table that has some missing values. And I'm going to tell you that the exponential function we're working with is y equals 25 times 2 to the power of x. What we want to do is use the function to find the missing values in the table. So let's begin with the first one here. We need to find what the value of y is when x equals 0. And to do that, you're just going to substitute y equals 25 times 2 to the power of 0. Anything to the power of 0 is 1, so this simplifies to 25 times 1, which equals 25. So our first missing value here is 25. And I'm going to do the other one down here when x equals 4. So let's do that one. So y equals 25 times 2 to the x, and in this case x is 4. So multiplying this out, you're going to have 25 times 2 to the power of 4, which is 16. And the product of 25 and 16 is 400. So here we have y equals 400, and we can fill that value into the table here as well. Now we're still missing one value, and that's when y equals 50. Now to do this, substitute the value of 50 in for y, and this is going to be equal to 25 times 2 to the power of x. Divide both sides by 25. 50 divided by 25 is 2. 25 divided by 25 leaves you with 1, and then times 2 to the power of x. Simplifying this, you have 2 times 2 to the power of x. Now when you look at this relationship here, 2 equals 2 to the power of x. How can you get the number of the value of the base, right, when you have this exponent? Anything raised to the power of 1 is the number itself. So that means that x here must equal 1, because 2 to the power of 1 equals 2, and that's what makes this relationship down here true. So that means x equals 1 when y equals 50. Let's try one more problem together. What I want you to do in this problem is to identify the graph that matches the following equation. And the equation we have here is y equals 5 times 3 to the power of x. Again, think about the fact that the general form here is y equals a times b to the x, where a is the initial value. So a is the value of y when x equals 0. Looking at this function right here, we see that a has a value of 5, which means that you're looking for x equals 0, y equals 5. Which graph has that point included? If I look at graph A, I see that 0, 5 is included in that graph. It's right here. So this one's still in the running. Let's take a look at graph B. Graph B has a y-intercept, or when x equals 0, of 3. So this graph is out of the running because we're looking for initial value of 5. Let's look at graph C. Graph C does include the point 0, 5, so this one is still in the running as well. Now what I want to do is just pick a value. Like, let's substitute x equals 1 into the equation and see what we get for y, and then see if we can match that on the graph. So y equals 5 times 3 to the power of 1. So when we simplify, 3 to the power of 1 is 3, so you have just 5 times 3, which equals 15. So now we're looking for the graph that contains the point 1, 15, in addition to the other point that we were looking at, which was the initial value of 0, 5. So let's look at graph A. When x equals 1, y equals 15, and that's this point right there. So now we've identified the correct graph, and I'm just going to make sure, let's go over here in graph C, when x equals 1, y equals 25. So this graph includes the point 1, 25. So now we know for sure this one is also incorrect. So graph A matches the equation y equals 5 times 3 to the power of x. In this lesson, you've learned how to identify exponential growth algebraically. Happy solving!